Hello again. I'm doing an example of where I want to graph y equals the sine of theta. I want to graph a sine curve. There's a lot of difficulties here for students. It's something that we assume a little bit too much as teachers maybe, and you have to break down the steps. First of all, here's the first step that I think you'd have to break down in order to understand this better. When students see the theta, they don't like it. First of all, it's actually y equals the sine of theta. There should be a parenthesis around there. Second of all, that doesn't really help. What I tell students is, you can also think about it like this. Y equals the sine of x. And then all of a sudden, just, whew, okay, I know what an x is, but I don't know what a theta is. And surprisingly, that really does help. So x is what I'm going to be putting into my graph, and y is going to be what's coming out. And in order to make a proper graph, at least initially, before you start memorizing what it looks like, is make yourself a table. Make yourself an xy axis. So I went ahead and I already did that. There's a few things that I kind of did knowing what the graph's going to look like, so that's something where I assume it. It's a luxury I have. Now when I'm substituting in values for x, there is something important to point out. I can't put in 0, well I can put in 0 actually. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Because first of all, if you're putting in 1 as in 1 degree, you don't know what the sine of 1 degree is. Yes I do, I can plug it into my calculator. Good. But it's not going to accomplish what you're supposed to do, because you're supposed to go 360 degrees, full circle. You're not going to do 360 plots. It's not going to work. Second of all, if you put in 1, 2, 3, 4, 5, 6, 7, 8, 9, chances are, even though you don't mean to do it, you're probably putting in radian measures. The sine of 1 radian is 57 degrees, so whether or not you mean it, 57 point something. So you don't mean to put in the sine of 57 degrees and figure out what it is. But that's what you're doing. So you can't just put in 0, 1, 2, 3, 4, 5, 6, 7. If it were that easy, that'd be great, but it's not. What you want to do instead is use your trig basics. I made a whole slew of videos on that if you want to refresh your memory on that. But if you know your trig basics already, you're going to be in good shape for graphing. If you don't, I suggest you practice it, because it is difficult. It really is for students to understand. So here's what I got to do. I got to figure out sine values that I actually already know. And students ask, well, I know the sine of 30. Well, some people do, some people don't. I know the sine of 60. I know the sine of 135. I know the special values. I'm like, good. That's a start. When we're doing this, though, you don't want to go and you don't want to just say, oh, okay, I'm going to put in 30 and figure out what my y value is. Then I'm going to go up to 90. I'm going to figure out what my y value is. Then I'm going to go up to 270 and figure out what my y value is. What you want to do is you want to go into increments. For instance, if this is 30, this better be 60, 90, 120, 150, 180. It better go in this, increments of a degree measure. If this is 60, it'd be 120, 180, 240, etc. I suggest, actually, in terms of parent functions, sine, cosine, and tangent, that the best increment to go in, and this is just my opinion, is 45 degrees. Each little dash here should stand for 45 degrees. So this is 0 degrees, 45, 90, 135, 180, 225, 270, etc. And actually you can go backwards too, and we'll get to that in just towards the end. Now this actually stands for what it's equal to. This is a 1, this is a negative 1. That would be higher if it applied, but it won't actually. So students say, okay, I'm ready. I'm going to plug in 0 degrees and 45 degrees and 90 degrees and 135, and they get really excited. They say, yeah, I'm good. And I say, see, I don't agree. You shouldn't plug it in degrees, because when you do more difficult problems, they don't actually measure them in terms of degrees, they measure them in terms of radians, because radians are more consistent as well with actual y value. Pi over 4's radian is actually 3.14 over 4, 3.14 divided by 4, which is slightly less than 1, which is quantifiable, and it's really cool. Yeah, students don't like that though. They want to put in degrees. I suggest you put in radians, especially for the more difficult problems. It just ends up helping them later. So instead of putting in 45, 90, 135, 180, put in its equivalent radian measure. As I said, students don't like that, but it does help in the long run. So this is 1 pi over 4, which is the same thing as 45 degrees. 2 pi over 4 is 90 degrees. 3 pi over 4. By the way, 2 pi over 4 reduces to pi divided by 2. 4 pi over 4 is pi. 5 pi over 4. 6 pi over 4 is 3 pi over 2. 7 pi over 4. 8 pi over 4 is 2 pi. 1, 2, 3, 4, 5, 6, 7, 8. Yeah, perfect. So pretty cool. You have to know what the sine of 45 degrees is off the top of your head. Very difficult for students to figure out. So yeah, you do need to know the trig basics. So sine of 0, I'm actually putting in 0, radians, not degrees. Sine of 0 is 0. I'm going to get back to pi over 4 in just a second. The sine of 90 degrees, or pi over 2, is 1. I'm going to get back to this one later. Sine of pi, or 180 degrees, is 0. Sine of 270, or 3 pi over 2, is negative 1. Sine of 2 pi is 0. There's a pattern that goes on there. Maybe you notice it. 0, 1, 0, negative 1, 0. There is a distinct pattern. It's a periodic graph, so it does do that. Now let's do this one. Pi over 4. The sine of 45 degrees is pi over 2. And this doesn't make students feel so bad when I end up doing it like this, because then they kind of start to see the connection. Sine of 3 pi over 4 is pi over 2. Sine of 5 pi over 6 is root 2 over 2. That's actually not true. I know it's not, but I'll get to it momentarily. Sine of 7 pi over 4 is root 2 over 2. It's not actually true. Each one is root 2 over 2, or like 0.707, but some of them are positive and some of them are negative. And what I tell my students is, well, if you know what the sine of 45 degrees is, great. But if I ask what the students, what the sine of, 225 degrees is, surprisingly they don't know, like most normal people. Unless you practice it, you're not going to know it. Well, here's what happens. 0, 0.707, 1. So it's going up. Now it's 1, 0.707, 0. Now it's going down. 0, 0.707, negative 1 doesn't make sense. It doesn't go from 0 to a positive number to a negative. It goes from 0 to a negative number to a bigger negative number, or a lower number in general. Then negative 1, negative root 2 over 2, 0. And by the way, root 2 over 2 in your calculator, if you want to plug that in, is 0.707. 007. If I want to graph this now, probably do this in a different marker. 0, 0 is right here. That's easy. Pi over 4 and root 2 over 2, probably like right there. Pi over 2, because each one here is in increments of pi over 4. That's what I'm doing. I kind of want to erase that though, because I don't want it to get in my way for later. You'll see what I mean. Sine of pi over 2 is 1. I don't even need to look at that one. Fortunately, that's 0. That one is negative root 2 over 2, there, and that one should be there, and that one should be, hey! Excuse me. Check it out. 1 pi over 2, 2 pi, 3, 4, 5, 6, 7, 8. It ends up working out. Now what's really cool about a sine graph is it's a periodic function that goes up and down continuously. So here I go. Now, if I decided to keep going, like 9 pi over 4, which is 415 degrees, the graph would be here, and then the sine of here. That's probably the best way to do it. There. And then the sine of 360 plus 90 is 450. The sine of 450 would do that. So it actually would just keep doing the same thing over and over. But I'm going to go ahead and erase that, because that's not really what I want to show right now. If you go backwards, it'll do the same thing. It won't go like this, it'll go like this. Like that. And it'll go on forever that way, and it'll go on forever that way. What's really cool is this. The amplitude, we're going to start talking about aspects of this particular function. The amplitude, I think that's right, how do you spell it, is the distance from the midpoint, or the midline of a graph, to the highest point. Or basically what you can do is you take the highest point and you subtract it by the lowest point, which is 1 minus negative 1, which equals 2, and then you divide by 2. So the amplitude is 1. The other way to think about it is this. Take the middle of the graph, well the middle of the graph is right here, and go to the highest point. It's the absolute value. So from here to here is a distance of 1. So the amplitude is 1. It's really cool. Something called the period is even more fascinating. The period is when something repeats. And I remember when I was first teaching this, probably not the most appropriate comment in the world, and I said, when you think of a period, what do you think about? And giggles came, and I thought to myself, what is wrong with me for asking that question, but I already did. Well, period is when this graph repeats. For instance, I said that this graph will continue to do, let me do this in a different marker though. Do something like this. You won't see off there though. And go like that. Well, the question is, okay, it starts at 0. I want to know when it hits 0 again, and that's the period. So we say, oh, it hit 0 right here. So that's pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4 pi. The period is pi. No, because then there's something else I ask. I say, when does it repeat? When does it hit the same spot, but in a repeating fashion? And here's what I mean. Right here, it's going up at 0. Right here, it's going down at 0. It's not repeating. It's hitting the same point, but it's going down, and this one was going up. You have to go all the way over here to see when it repeats. This is where it hits 0 again going up. This is where it hits 0 again going up. The period of this graph is 2 pi, or 360 degrees. Basically what that means is, when does the graph start repeating itself? It repeats itself every 2 pi. Every 360 degrees, the graph will start going back with the values again. That's the period of a sine function. It's also actually the period of a cosine function too. So those are things to keep in mind, the amplitude and the period. You made your little sketch graph. As I said, the graph can continue to do this actually, but we're not going to go ahead and do that. And we'll continue to do this, just repeat over and over again. But when we talk about a sine graph in its most general form, we talk about it from basically 0 to 2 pi. And something else for students, and this helped me as a student too. If you ever want to know the difference between a sine and a cosine graph is, and I'll do cosine later, is the sine will always start at 0. That's it. When you plug in, or when you put in 0, it's going to start at 0. When you put in 1, when you put in 0 for the cosine, then the y value would be 1. So the sine graph will start here, a cosine graph will start here. That's the only difference between them. Well, there's another difference too. But anyways, that's basically it. I want to talk about how you can manipulate a sine graph as well, and we'll see how that goes. But for right now, have a good day. Goodbye.